Hello guys, this is Easy Electronics channel and this is part 2 of how to make a breadboard power supply. Let's get to it. Okay, so I have drilled 2 holes for our potentiometers, 1 hole for our selection switch. I also drilled a hole and filed square or rectangular hole for our power switch, and there's a hole for our multimeter, I mean voltmeter. I'm gonna use a really small bit here, make a whole bunch of holes around the perimeter and then just get it out. Let's see how that works out. So okay, so that's how it looks. So we're back here at the desk and I have to punch this out, but yeah, I don't know how. I think I'm just gonna try it with a file or something. Oh, there we go. Okay, so it simply breaks off and we just have to file it just a little bit. Okay, so I had filed our rectangular hole and it does look like the voltmeter. Why do I keep saying multimeter? Anyway, it does fit inside, so let's try it from the side it's actually gonna go. Success. Voila. Looks good. Okay. Right when you almost done, take the other part and then you realize, whoopsie, everything doesn't quite fit. So now, by the looks of it, we have to cut the top fin off all the way in order to get it to fit. Yeah, that's a little bit not good. See how that works. Alright, so I have cutted the fin off, as you can see, so now it does fit. It doesn't look as good as it did before, but it's gonna do the job just fine. Alright, so a little update. So what I have done is I have cut out the holes for this input jacks and everything is nice and snug there. No, it does not touch the potentiometers. I made sure it doesn't. And I also cut it for tiny holes. This is our output terminals for wires, okay? I'm gonna do my best to fit them in like so. So here's one, here's the other one, like this. okay, on the side, so you can screw the wires in and tie them up right here. A really convenient way, okay. And we still have a lot of space inside for our circuitry, so that's pretty good. Okay, so let's do this. Okay, so what I'm doing next is I just have glued two of these terminal blocks, and they have slots in them. I did not realize that actually, but oh my. Okay guys, so what I have just done is I took two of these terminal blocks, and they have little slots here. So this one comes out, this one goes in, and they kind of slide together nicely. So what I did is I did this. They connect together, as you can see, and I separated them just a little bit and put a drop of super glue in there. This gives us an ability to have it all connected together when we put it in, so it actually stays together. And then on the other side, we'll put a little bit of prototype board, solder the connections up. Beauty. Now the next part here is what I'm doing is it's kind of messy, but here's the problem. You know, we have a heatsink here. I want it snug to the box, and I have to put my transistors somewhere. So there has to be a hole right here for my transistors. So that's really what I'm doing. So I'm just getting this piece out. Okay, that should do it. So now we have a nice hole for our transistors. LM3317 will be separate. They don't require a heatsink, but these tip 41C transistors need a heatsink, so that's what's that for. Okay, so what we're doing here is I will be using which two? Okay, I will be using this hole and this hole. I'm just gonna mark it so I don't forget. This and that hole, and I believe these are the proper thread M3, I believe. And no, okay, that's not good. Now there's a little problem. I always use M3 screws, really fine. Focus, come on. Okay, so I'm using a really fine thread screws M3 for all of the transistors or packages I'm using. I have a whole bunch of them, so that's what we will use today. But there's a problem. On this heatsink where I took it off of the circuit board, they used self-tappers. Now it's not the same thread as this, so I have to tap my own thread on there. Hopefully the diameter is the same. Yeah, by the looks of it, it's the same. So looks like we're tapping really good in there. It's nice to have tools in the shop or in the lab, so you can really get the results you want. Okay, so we got our two holes tapped, and now we'll put some thermal compound on there. And let's put some thermal paste on there. Yeah, it's always good to use a thermal paste. Like you can use a thermal, silk pad as well, but you know, thermal paste gives you the best heat transfer, right? That's why it's used on the computers for your CPU. So we'll bend these up as well. So we got our transistors in here. Put our heatsink here, and that's what it looks like on the inside. Yeah, it's a little bit sketchy, I know, kind of close, but we will make it work, and it should all work pretty well. So let's get to soldering all this up. All right, so I had done some soldering aside. So I have soldered the negative that runs directly to our output. Okay, here, and I soldered the positives to our two transistors. Okay, so we are getting closer and closer of actually getting this to work. I'm really excited. I'm really excited about this. So hopefully it turns out good. Okay, so what I have done at the moment is I added a reverse protection diode here on the positive side. Okay, so this is just making sure we do not connect reverse polarity. I also drilled another hole here for a red LED. This actually shows me that the power is actually connected. There's 680 ohm resistor. Okay, so I'm slowly jump wiring the things here. It's getting to look like what it should look like. Okay, so that's what it looks like at this stage. We did most of our wiring. I got my two LM317s wired up. No PCB, no nothing, just a jumpy wire configuration. I find it to be kind of the best at the moment, unfortunately. Okay, so we try to get everything compacted in there. So it's gonna be in a small box, but it packs lots of stuff. So yeah. Hello guys, today is tomorrow, day 3 of this build. Okay, and we have done lots of things at the moment. So I have added an LED indication when the polarity is correct. It serves as a power LED as well. And we have protection diode right here, which is heat shrinked. At the moment, I heat shrink my base resistors as well, and you know, I hook everything up. It works, looks good, but it jumps around. The voltage kind of jumps up and down, and I went, how does this can happen? So I go here and I check all the wiring and blah blah blah, and I miss the most obvious thing ever. You would never believe what I missed. So on this two LM317s, I have two electrolytic capacitors, so input and output caps. And well, while one and the other connects to pin 2 and 3, the other end of the caps, this right here, has to go to ground. And guess what I didn't do? I have the caps, but I do not have any connection to ground. That's why it's jumping around. So, yeah, I did consider adding diodes on the basis to actually go to full zero when I go down, but I decided not to. It's a little bit useless feature, since you know we can display voltage over 3 volts on here anyway, so why would I even bother doing that? So yeah, so everything seems to work okay. The switches work, the selection works, the voltage adjustment works. So let's get it all up and running, and I will show you how it works. Alright, so it looks good. Everything is working. Oh, it seems to be working. We have two channels, channel 1, channel 2. A little bit hot glue here and there to hold it in place. And now we will connect everything and see how it works. So what I'm gonna be using is I will be using this amp meter to see the input current. Okay. So if you wanna know how to make one, there will be annotation somewhere on the screen. Alright, so negative goes to our amp meter. Okay, then our negative exits our amp meter and connects to our power supply, to the negative, just like so. Our positive just getting connected there, and that's it. Now for a load, I will be using a 12-volt car light bulb, which perfectly fits in here, and just enough to test it. So as you can see, I can trim the voltage and 6.57, 5.29, and then 4.2, blah blah blah. So as you can see, the thing works. So we cannot display voltages smaller than 2.5 volts. This is 2.43, but you can barely see it, so I'm gonna say under 3 volts. Alright, so we switch to this channel to show the voltage on this channel, and voila, it's working. 5.24, 7, 8, 9, yep, about the same amount, same current. Okay, and as you can see, when we are fully off, we do take current. That is because our voltage regulator cannot go down to 0 volts. I decided not to excuse me, do that. I just didn't have enough space in there for 6 diodes to go. So 3 on one voltage regulator, 3 on the other, that would bring it to 0. I just didn't have the space there, so I decided not to. But we are taking 0.36 amps right now, fully down. That's because we have 1.3 volts output. So when I turn it off all the way, it goes to 0. So the bulb is still getting power even now. Now the heatsink gets hot, because what we're essentially doing, we're taking 0.36 amps at 1 point something volts from 17 volts. It's gonna produce lots of heat, so that's why we have a beefy heatsink here. Check it out, guys. This looks so good. I don't even know what to say about it. It just looks good. We have our 3 breadboards, and we have our power supply here main. It's not connected or anything. I can still move it around, but it's kind of the layout that I want. So here, this is where this thing should go. I don't quite like it there, so we'll get rid of it. But overall, it's not that bad. So all we gotta do now is to glue this to the aluminum plate, flip these over, and take off this double-sided tape thing here, and stick it on here, and do some connections here to actually connect all the buses properly. And yeah, that's about it. Alright guys, so what we have here is I have glued them to the board. As you can see, they don't fall off or anything like that, so they are nicely connected, glued to the aluminum plate. Now what I'm going to do now is I'm going to get some double-sided tape on here on the back and glue this guy here. Alright, so what we have here is I have added pin headers like these, cut them to size, and they're nicely fit in there. And what we're gonna do, I have pieces of PCB board, and we will add them like this. Alright guys, so everything is assembled, and I quite like how it looks. So as you can see, it's all nicely done, aluminum, right, not going anywhere. And the design is quite simple for you know, doing breadboard things. So this bus, this and this are the same, and this and this are the same. So pretty much the top knob controls all of the top power buses. The bottom one controls all the bottom power buses. So I thought that's maybe that's pretty much the easiest way to get this done. So what we're going to do next is we'll put a load. We use a 12-volt light bulb like this, which I will connect across the bottom bus, which will be controlled by this knob. Then I have two 6.2 ohm resistors, and I will connect those across the top power bus. And what this will give us is we'll get two loads on each, two loads, and you'll be able to see how it works and how it performs. Oh. Close enough. Okay, so 3.03 volts on the power resistors, 8 volts on the bulb, and I will actually cover the bulb with this little thing I didn't even use. So just covered the bulb, it's just too bright. So okay, so that's good. So as you can see, we're taking a 1.28 amps, okay, and the voltage is stable here and here. Okay, obviously we can decrease it until it so as I said, you can barely see it. It's 2.52 volts. You can barely see it, but it's on there. Okay, you can clearly see 4 volts, no problem. Close enough. Okay, so we switch to the other rail. Okay, 8.0405. Okay, so it's good. It's good. It's nice little power supply. Thanks for watching. Hopefully this was helpful, and hopefully you can make one yourself. These are awesome for prototyping because now you have so much room here to put your chips, your circuits, and everything else. And now we have a power supply we can actually use to power our projects. This is really cool. So now it's just one more thing to make life easier for electronics. Don't forget to like the video and also subscribe to my channel so you know when a new video comes out. And see you next time. Peace.